This is question 12. Diffraction gratings. You might have looked through them, either little slide things or little telescopes. Split light into beams that travel in different directions. And here's a light wave. Give the wavelength. So the wavelengths are, it's the difference between, say, two peaks. So that could be the wavelength there. There's another one there. So between 600 and 1200, or 0 and 600. So that's 600 each time. A diffraction grating is used to analyse sunlight, and you get a big central white line when you look through it, and either side a different band of colour. So you remember seeing those, and they become increasingly blurred the furthest they go from the white line. So why the white line is bright, and so you need 2 points here, and you can suggest, it's all to do with peaks and troughs and interference. So we can say constructive interference. That's for all of these waves. Will do that. You could maybe talk about superposition, where you've got two waves, and the peak is going to be twice as high, and they've got the same path differences. So path differences from the grating are identical, and all of those wavelengths are in phase. All of those waves are in phase. So that's telling you really why it's bright. Why is something really bright? There's lots of interference. So for example, the easiest answer there is you get constructive interference with an explanation of that, the waves are in phase. Why you get this pattern of colours? Well, you need 4 things now. So let's say what this diffraction grating is doing. So at the diffraction grating, you can say, well, this white light is made up of different colours of different wavelengths. So light is made up of colours, and we're talking about different wavelengths. So here, where we've got a wavelength of 600, different colours will have higher than 600 or lower than 600, and light will diffract when it goes through this grating. So light will diffract, change direction, bends. Let's put that into English. Bends. And the angle at which this happens depends on what we've just said. This different wavelength depends on wavelength. So that's what happens at the diffraction grating. why do you get this pattern of coloured bands? So coloured bands, because you're getting constructive interference when you've got the path difference making constructive interference. So when you get a whole number of wavelengths, so you're getting that constructive interference again. So constructive interference when the path difference is a whole number of wavelengths. And so each colour will meet at a certain place and form a line. So each colour will meet and form a bright line in a different place than other colours. Two other colours. So you're saying why they're changing? What's happening? What's the grating actually doing? And then explain the results that you get. A little bit tricky that.